Hello everyone, Kevin here and welcome back to the course. So in this episode we are going to be doing data preprocessing and under that we are going to be working with pandas, alright? So in order to do data preprocessing, we'll first need to have some knowledge about the libraries. In this particular video we're going to be having a look at the libraries called pandas, alright? So if you haven't seen the Python course or if you don't know how Google Colab works, I would highly recommend that you go check the Python course out. It's on the channel. It's 3.5 to 4 hours long and you'll get to learn everything. So it's a prerequisite for this video. Alright. So let's just first go and connect runtime on Google Colab. I have attached the link of this Python notebook in the description below so you can have a look at it and you can code with me. I would recommend, instead of, just opening my collab notebook and running files with, running cells with me, you type this out, pause the video, or use a second screen or do something like that, do a switch between windows and code with me, alright? Instead of just running my file, if you will code it yourself, it will be better. So once we are able to connect to the runtime, we can start. Okay, so we have been connected to runtime, alright? We have got the RAM and the disk space over here. And what that means is basically now you can perform operations, you can write code and you can run them, alright? We have been allocated a space, a GPU to perform the actions. So first of all, whenever you are doing pandas, you will first need to get the library, alright? So you need to import that library and then whatever functions within pandas you are using. So technically you need to do pandas dot function name, right? But because writing pandas dot function name every time would be a very big hassle, what we can do is we can use the as word over here, and what that will do is that instead of writing pandas each time, uh, writing PD will lead to pandas, alright? So let's say I want to do something like pandas dot function. I can use PD dot function and that will work the same. So import pandas as PD. Let's just run that. And it shows a green tick over here. So that means that pandas has been imported, alright? Now, for learning pandas, we are going to be having a look at the Marvel characters dataset, alright? So it is freely available on Kaggle. So I'll just give the credits to it. Kaggle is a website, if you didn't know, where you can get you have competitions, you have data sets, you have notebooks, and you can get unlimited data on it. It's there's so much data that you can analyze or that you can do for you can look for your projects. You will find something or the other on Kaggle. So we are using the Marvel characters data set by Syed Asim Ali Shah. Alright, it's just 4 months ago. I have put the link over here, so you can just open that link. And over here in the data set, what we'll do is we'll click download. You'll need to log in to Kaggle first, download this, and I'm just gonna write Marvel character data set. Press save. So that has been downloaded. Let's go to our desktop. Let's extract it. Let's extract it just on the desktop. So we have got a Marvel movies CSV, alright, Microsoft Excel, comma separated values file, alright. If I were to press Alt Enter and get the properties of it, it is a .csv file, alright. It's not a .xlx, it's a .csv file, alright. Now we are gonna, we're gonna give this the name of Marvel underscore char, right? Because that's the name that I've used in the data set, right? In the for the notebook. Let's just go over here and let's go over here in the file section. Let's upload our marvel underscore char .csv file. Okay. So each time that you connect to your runtime, or each time your runtime gets deleted on its own, usually upon inactivity or after you cross a certain limit, your data gets thrown in the dustbin. All right, all of the data that you upload over here, all of the files that you upload, they are disposed of. So each time you connect to a new runtime, you will need to upload your files again. Now, if you buy the Pro version of Collab, that is, I think, Collab Pro Plus, you won't have to deal with that. So that's there. We're just gonna work with this because it's free and we are just learning. So the first function is read underscore CSV under pandas, and what it does is it creates a variable of the data type of a data frame. So we are calling it df. Now whenever you write df, we will assume that we are always referring to the data frame, the data set. All right. So df equals to pd, that is short for pandas dot read underscore csv. All right, and we have mentioned the path to the file. Now I'll double click on this, and you'll be able to have a look at the data set as well. That is loading. So we have, yeah, we'll have a look at it ahead. So when we ran this, what happened was we received a green tick, and now what has happened is that the variable df now stores the entire data set that is under marvel underscore cat.csv. Right, now to check if it has been imported properly and to have our first initial look at the data set, we're going to use something called df.head. All right, now what head does is it prints the first 5 rows of the entire data frame. So let's just run that, and there we have it. We have the first 5 rows, index 0 to 4, because in programming we count from 0 and not from 1. All right, so you have got the name. So we got Spider-Man, we got Captain America, we got Wolverine, we got Iron Man, we got Thor, right? Popular Avengers, popular Marvel characters. Then we have got their ID. All right, so whether their identity is secret or it's public. So uh, as of in general Marvel, Spider-Man, Peter Parker has a secret identity. Not now, obviously, but in general. Captain America is a public identity, Wolverine is a public identity, Iron Man is a public identity, and Thor has no dual identity. Alright, Thor is Thor. He doesn't have any secret, he doesn't have any public identity. So that's our ID. Then we have align, so that they're good, that they're neutral, that they're bad. So if we were to have a look at the entire data set, you will find different variations. There's good align, bad align, neutral align. Then you have the eye color. All right, Spider-Man has hazel eyes, Captain America has blue eyes, and so on. You have the hair color. All right, some might be bald as well. So we'll have bald over there. Then we have their gender. All right, sex, male, 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 male. All of them are male. We'll have female for Black Widow. All right. We have something called GSM. We'll look into it further. Then we have alive, so that they're living, whether they're dead, right? And then you have the number of appearances. So in the comics or in the movies, how many times, like combined, how many times they have appeared, right? How many different comic books does Spider-Man have a role in, all right? That's 4043. And when did Spider-Man appear for the first time in the Marvel thing? It was August of 62, right? So that's 1962, and so in the year 1962, in August, the whatever comic book has been released, it had Spider-Man for the first time in it, right? With Captain America, he was introduced in 1941 in the March month, and so on. Okay. Now, similarly, another variation in this is that let me create another code cell and we write df.head. Let's say you don't want to see 5, you want to see 10 rows. So I just write 10 over here and then run this. And what it will do is it will print the first 10 rows for me. Alright. So, like Benjamin Grimm has no hair. Alright. So that's something that you can have a look at. And that's how you can use the head function. Similarly, because you have the head, we'll also have the tail. What tail will do is, you might have guessed it, it will print the last five entries of the entire data set. So that's these five, 16,375. We have 16,375 different characters in this data set, and the last 5 of them are these. You have bad characters over here, and green eye, blue eye, black eyes, bald. These both are bald. Alright, Thanos' son is bald. So that's new knowledge for you. Now there's another function called print data frame. Alright, pretty simple. It will print it. However, it won't be a visual delight to watch them as it was over here. So what it does is it prints everything, but since it is not appropriate to print the entire 16,375 entries, it will just print the first 5 and the last 5 and dot dot dot, which indicates that all of them are printed over there. And this is just like different columns because we don't have that much width. We have just put the columns in, we have split the columns over here. So we have the first 3 columns over here, the next 5 6 columns over here, and so on. So 11 columns and 16,376 rows. So that's the print version of it, but it doesn't look good. So you can use this head or tail. Now this is how we have checked that our file has been read properly and our data set is complete. Alright. Now let's say over here we had a CSV. Let's say you had a Excel file or you had a TXT file. So let's just head on over to desktop. I'm assuming all of you have Excel or some substitute to it. So let's just open this with Excel. Alright. And we can have a look at the data set. Let's go to file. Let's go to save as. Alright. And on desktop itself, we'll save it as mara_cat, but in the type we'll go to Excel workbook. Alright, so that should be .xlcx, I guess. Alright, we'll save it as that, and when we refresh over here, what you get over here is a new file which is a .xlsx. Alright, xlsx. Let's just confirm if we have got .xlsx correct. Yeah. Alright, and then let's again head on to our original file. Let's again go to save as on the desktop, and let's keep it as a text file. Alright, and let's just save it. We can close this off now, and over here if I press properties, we've got a .txt file. Alright, you can even open it, and what you will see is it's a tab delimited data set. So over here, if you will have a look, Spider-Man, secret identity, good character, here's a lie. All of the data has been mentioned, however, it isn't aligned properly. After each entry, a tab space has been given, and however, not everything has the same length. Their names are longer, so that's why it has, gotten a bit mixed up. So let's just, head on over to our file and let's upload these two files. So I think this is the CSV, this is the text on XLX. Let's open them and let's just wait for them to get uploaded. Meanwhile, let's comment out this and let's run the df_xl. All right, let's run that. So data frame variable df_xl was created. The Excel file contents were read into that variable, and then you printed the first 5 rows. And as you might have spotted, there's literally no difference between this and the df head that we printed over here. Now, when you have a .txt file over here, uh, the file that we just created was delimited by a tab. So as I said earlier, each column was separated by a tab. In some of the .txt files, it is separated by a comma. So in this case, what we'll do is we'll use a /t, alright, and that indicates tab, alright. So the delimiter is a tab, so it knows, and now whenever it will come across a tab, it will consider it as a new column, right? So let's just run this, and again you can see that it's perfectly fine, right? It's the same as the above one. So that's how you can work with .txt's or .xlx's files. All right. Now let's come to the second part, which is reading the data. All right. So you imported the data into your df variables. Now how can have a look at them properly? So let's use df.columns. What df.columns will do is it will give you a list of all the different column names given. So it will give you name, ID, align, hair, gender, all of it, right? It will just give you an index or an array of all the names of all the column headers. Now, let's say you just want to print a particular column. You can use you can use square brackets, and then you can just write the name of the column, and that will do the trick for you as well. So df and name, and we are printing the name column. Let's say I want to print the gender column or the sex column. If I do that, we got male and male, female, whatever it is. All right. So that is how you can run your you can print a specific column. Now let's say you want to print multiple columns. What you can do is you can create a sublist inside it. So just write name, ID here. So there's a list of 3 columns, and then they are printed they are fetched from the data frame, and then they are printed. Let's run this. and you can see we got name, ID here. Alright. Now let's say you want to print a specific row. For this we'll use the ilock function. Alright. What the ilock function will do is that it will print, or it will fetch whichever index of the row that you enter. Alright. So let's say I wanna print the fourth row. The index of the fourth row is 3 because we count because we start counting in programming from 0. 0, 1, 2, 3. So if I do 3, I should get the data of Iron Man. Alright. So let us run that, and there you have it. You have all the data of Iron Man. You have Iron Man's name, you have identity, you have align, you have eye, hair, text, yeah, appearance, everything. All right. So that's your ilock function. All right. Now let's say on a printer range of rows, this is similar to slicing. When we did slicing of strings and slicing of lists, what you do is you write the first element that you want to be included. So here you want Iron Man to be included. So we're going to go from index 3 till index 8, but we don't want to include index 8. So the elements or the rows with the index 3, 4, 5, 6, 7, the 5 rows should be printed. So let's run that. And what we figure out is we got 3, 4, 5, 6, and 7. Alright? And then we don't get 8 because that's how slicing works. So ilock function also works with slices to print specific number of rows. Now let's say you want to print a specific cell. Alright? So over here what it was, we sliced it. Now you might know coordinates, graphs. So assume the entire table to be a graph where your y coordinate is 3 and your x coordinate is 0. Alright, so that's Iron Man's name. So if I were to run this function, we should get Iron Man's name, and yeah, we get Iron Man's name. If I want to print Iron Man's, let's go over here, and if I want to print Iron Man's eye color, alright, what we have to do is we have to count. This is the first, second, third, and fourth. We want to print the eye color, so that's the fourth column. So let's just head on over here, and the fourth column will have an index of 3. So let's run that, and there you have it. Iron Man has blue eyes. So that's how you can print a specific row or a specific cell. My bad. Now earlier we just got the rows, whatever we want. It's just manual work that I want the row of this, I want the row number that. Let's say I want to get a row based on the year of their appearance should be 2003. All right. If I want to do that, I can create a lock function. All right. Inside that df.lock, and I can mention that uh, the year column should have the value 2003. So whatever row that I'm looking at, the value stored in the year column should be equals to 2003. So let's just run that, and we get over here all of the characters that were appeared for the first time in the year 2003. All right, fair enough. So you can make a sense of it that we were using df.ilock, and then we were saying that index number whatever it is, right, 5, 6, 7, 8, whatever it is. Now what over here we did was we said that all the indexes which have the specific value should be included over here. So all the indexes having the value of 2003 in the year column should be included, and all of them got printed. So that's how your lock function works. So now let's have a look at sorting values. Alright. So in order to sort values, you have the simple function called sort underscore values, and you can sort them according to the column. Alright. So let's say I wanna sort the entire data set according to the name and should be alphabetically. So all the characters that start with, let's say, A should be listed first, then with B, then with C, then with D, and so on. Right. Also, you'll have special characters before, so numbers will be printed before. So if I do that, we've got uh, a quotation mark over here, then we got 107, then we got 11, then we got 115, then we got 14, and then at the end you can see we have Z, 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 and we have got backslashes, right? So if so that's pretty much it, how you can sort the values according to one column. Uh, to arrange them in a decreasing order or in a descending order, you can so by default ascending is always equals to true, but if you write a comma and you specify ascending equals to false over here, what it will do is it will sort them in an inverse manner. So you'll get the same thing, but starting from slash and z and then going up till one till digits. Alright. Now let's say you wanna sort multiple columns at once. Already you wanna sort the name as well as the I. Uh, so if I were to create a list of columns, we'll get the proper result that we want. Alright. So that's how we can do that. Also, the same applies over here. Ascending equals to false, and that will just reverse it. One special feature in this is that let's say you want the name column to be in ascending, while you want the I column to be in descending order. Alright. If I were to run that, what will happen is one of the columns will be in ascending and another will descend. Where this is particularly helpful is that let's say you've got multiple entries with the same name. Alright. Let's say you have my salary entries. Alright. That in the month of January, Kevin was given, let's say, 100 rupees. In the second month, he was given 120 rupees. The third month, he was given 90 rupees. Then he was given 130 rupees. So let's say you wanna order them in a specific way. You have an entire company, and then you have data set of like salaries of 6 months for each and every employee, and you wanna sort them out in ascending order. So what you will do is you will say that I want I first want to sort them in the order of name. So all of the Kevins, all of the Davids, all of the entries of all of these people would be first sorted according to name, and then according to their salaries, we can sort them again in increasing or decreasing manner. Now to do that, we can use this function over here. I'm just explaining this function. This data set isn't particularly good to explain this function, but I hope you understood from the example that I just gave to you. Now let's move on. Now let's say you want to make changes to data. All right. Uh, let's say I want to add another column into the data frame. All right, and that should be the sum of the year that they first appeared in and the number of appearances that they have made. Right. So over here, as you can see, let's take Spinner over here. He appeared for the first time in 2007, and okay, this is let's ignore that. Let's take ZZZAX, alright. He appeared in 1973 for the first time, and he has got a 32 total appearances in the comics. So, what will the sum of 1973 and 32? That will be 2005, if I'm not wrong. Yeah. So, the answer for that AX should be 2005. We want another column to give this sum to us. Alright. So let's do that. Let's create a new column called total, and it will be the sum of appearances column and the year column, and we print the head of the entire data set. So let's run that. And as you can see over here, we got a total column which is 6005, which is 1962 plus 4043. If you do the math properly, you will get the total as 6005. All of it is applicable for all of them. Alright. So that's how you can create new columns and give those columns a value based on the year or based on some other dependent values, right? Now let's say you want to drop this column, right? You can use the df dot drop function. Now the problem with this is that what it will do is over here in this cell over here, we added a new column to the data set. Now when we ran this function, what it did was it displayed the data frame without the total column. It didn't remove it. It created a new temporary variable over where all of the data was there apart from the total column. it didn't remove it from the DF dataset. So in order to implement that, we need to do a simple thing where RHS equals to LHS. Whatever value is present in the right hand side is assigned to the left hand side, basic rule of programming. So DF equals to DF dot drop, and what will now happen is that DF that we just created will now totally lose the total column. So, well, in order to test this, what we should have done is we should have added another code over here, which would have done df dot head. Obviously, we don't need a 5 over here, and let's just do one thing. Let's run this. Our total column now. We drop it, so we temporarily don't see the total column, and then we print the first five rows, and you can see over here that df still has the total column over here. So we realize that, and hence what we do is we redefine data frame variable and give it the value of the dropped thing. All right, so whatever we got over here, that is assigned to the df variable now. So let's run that. Let's print it now, and what you will see is now you can't see the total column. All right, so that's how you can add data and remove data. So that's a drop function for you. Now let's say you want to save this data. As we did read underscore csv, over here to save it you have two underscore csv and xl and the txt, and obviously you can mention separate over here. Let's do a comma over here, and let's run this, and let's open the file section. Let's let's refresh it now, and you can see that we have got three modified files over here. If I were to open them, yeah, if I when I open them, you can see that we have got a txt file with the entire data set, which is separated by a comma. If I were to read this, if I wanted to read this modified.txt again, what would I use? I would use the df dot read underscore pd dot read underscore csv function, and then I would use the delimiter equals to comma. All right, because that's the separator that we have used. You can also check for modified.csv and modified.xl. Let's wait for them to load. Yeah, so we got the CSV over here, and we can download the Excel file. All right, let's just close this up. We don't need this. This is how you can save your data. You can create checkpoints as well. All right, so let's say you did all of certain pre-processing. Now, just to be on the safer side, what you do is you create a checkpoint. You create that whatever data frame, whatever changes that I've made in the data frame till now, I want to store them as checkpoint one. All right. So later on in the code, if I make some mistake or if I want to retry the original data, I can just call it and I can be good to go. So saving your data is a important thing that you should know about. Next, you have filtering data. All right. So let's say you just want to print all of the entries of all the characters which just have blue eyes. All right. So we can again use the lock function for it. And again, what we did over here was we printed all of them with blue eyes. So let's just run that. And you can see that all of the characters with blue eyes have been printed over here. Next thing is, let's say we want to print everyone with blue eyes and who don't have any hair, who are bald. So what you can do is you create a one requirement, use a and symbol over here, and then you specify your other requirement. So let's run this, and what that should do is it will print all the characters with blue eyes and bald hairstyle. All right. Now, sometimes instead of using the and symbol, you want to use the or symbol. That I want to print everyone with blue eyes or who are bald. So let's run that, and that works as well because Captain America has blue eyes and white hair. So because he has blue eyes, he falls into the condition and he is printed. Over here, Jack O'Lantern imposter has is bald. Even though he has brown eyes, he is bald, so he's printed over here. Now we can also use inequalities to sort out the data. So let's say I want to just print all of the characters who appeared after the year 2000. All right, so who are comparatively new. Spider-Man was in 1900 something. So if I just want to have a look at characters who have blue eyes, who are bald, and are have made their first appearance after the year 2000, I'll create a new data frame variable and I will assign it to that. Let's run this. And when we print new data frame, we get, let's say, uh, John Aman, right? He has blue eyes, he is bald, and he appeared in the year 2007. You see how strong this is and how fast it is. It's so easy to filter out data. Let's move ahead. Uh, Now over here you can see that the index values are a bit scuffed. Alright, we have got 649.1074 for the new data frame. We don't want that. We want our new data frame to have index values of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So what we can do is we can use the dot reset index and drop equals to true. And what that will do is it will reset the index. Let's print this, and the new index is 0, 1, 2, 3, 4. Alright, and again we'll save this as a filtered.csv thing where only we've got the people who are blue eyes, who are bald, who are born, who appeared up 2000, and their indexes have been reset. Alright. Now let's say you want to filter all of the uh, all of the rows with a specific word in them. Alright. Let's say I wanna just find the rows which have the word Tony in their name. I can run this function, alright, which is simply uh, data frame name dot string, alright. So we are just telling it that it's a string data type, and then we are using dot contains function, and then we say whatever we want, alright. So Tony. So obviously we got Iron Man, who is Tony Stark. We have got Tony Masters, Tony Masterson, Tony Trainer, Tony Washington, Tony Conwell. And this can also have like anything like, let's search for my name, Kevin, alright. Let's see if there's a Marvel character. Yeah, oh my god, we got so many Kevins. We have Kevin Plunder, Kevin Masterson, Kevin Marlowe, and let's do something like Tom. And even that works perfectly. Alright, Tommy, taping Tommy, Tom, right? So that's filter. Let me just keep it to 7. I'll be proud that there are some variants of mine in the Marvel universe, I guess. Now let's say I want to find everything apart from Tony. Alright, I want all the rows apart from those containing the word Tony in them. I'll use the same code, but I'll put this funny looking symbol over here, which will inverse the entire effect. So let's run that. And what it will do is it will say that everything other than Tony. So as you can, if you might remember, number 3 was Iron Man, and he can't be seen anywhere over here because he had the word Tony in his name, and that's just missing. So now let's have a look at how we can get rows which are having some specific values like combination or something like that. So for that we're going to use something called as regex. All right, now what does what regex or regex, whatever you want to call it, it stands for regular expressions, and it is used to create a template like format to find words. So let's say my name is Kevin, Kevin, right? So let's say I want to find everyone who has the word VI inside their name. So I could create a regular expression with let's say any characters before VI or any characters after VI, but VI should be included inside the name. And I could create a regular expression like that, and then create a performer search like that. So over here we are gonna import re for regular expression, and then we're gonna use the df.lock command, and over there using the same contains function that we used above, you're going to create a regular expression which is either blue or black. And then because blue and black was capitalized, right? That's why you're going to go right as blue eyes, black eyes. You could even write space eyes over here, and that should work perfectly fine as well. But we're just going with blue or black. Regex is true, and null values are ignored. So NA equals to false. So let's run this, and you can see that everyone with blue eyes has been listed over here. The first one, Spider-Man, had hazel eyes, right? So his name isn't here. Similarly, 16,361 two are not seen over here because they might not have blue or black eyes. So that's there. Similarly, if you don't want to include the capitalization, there is just this one thing called flags and capital I. So through this, capitalization will be ignored and you will be able to perform a search better. So let's say there is someone's name starting with a capital VI, alright? In the previous example that I gave, if I have just kept a small v and a small I, the guy with starting with VI won't be included in that. So we could use this and we could be getting a proper entry over here as well. So let's just run this and you'll see that the result that we receive is the same one. Uh, Now, if we wanna get again, this is again an example of regular expression, which are starting with a specific string. So let's say you wanna find Tony, Tom, etc. You can use Tigo over here, and then this is the format for regular expression. You can have a look at it in the documentation as well. And then you can put A to Z over here in square brackets, which will indicate that any letters, any amount of letters, the asterisk implies that any amount of letters from A to Z can be included. So let's run this and you will see that we get Tony Masters, Todd, Arylis, Topaz, Tom. Why didn't we get Iron Man over here? Because his name is Iron Man and it doesn't start with the word TO, right? And that's why Tony Stark wasn't found over here because our format said that the name should start with TO and then it should contain any number of letters over there. So that's it for this section. Let's go to conditional changes. So let's say that you come up with some idea like I've come over here that hazel is just like brown. Okay, so everyone who has hazel eyes, I want to change that value to brown eyes. All right. So again, we can use the lock function to get the location or get all the rows with the entry as with their eye color as hazel. I got Spider-Man, Catherine Pride, or Octavius. All right, all of them, and then all of them have been listed. We got 76 people with hazel eyes, and then we run this command, which what it does is it will select that all those rows, all right, all those rows which have hazel eyes in them, and then the I column, right? Remember this when you use the log function for uh, finding a particular cell. We did this that the index of the row and then the index of the column. So over here, instead of index of the column, we have put the name of the column, and then all the specific rows that fall into it, we are putting them as all those rows containing hazel eyes, and then we are changing all of those entry to brown eyes. Right. So let's run this. And what we find over here now is that Spider-Man now has brown eyes. Captain America. Uh, okay, yeah. So we printed DF, alright. So that printed the entire data set. And now instead of hazel eyes everywhere, we have brown eyes. I could even do something like df dot lock and then df I is should be equals to brown eyes now, and we'll observe that we just receive people. We receive 76 people. Okay. Yeah, so brown eyes is also another entry. So now hazel eyes and brown eyes have been merged. So now there isn't a difference now. And if we were to do something like this, that df dot lock all with hazel eyes, we can see that there are no entries now. So everyone with hazel eyes has disappeared, snapped out of existence. Now we can also use one condition to change the value of any other column. So let's say I were to say that if someone has a secret identity, then they are good characters. Alright. If anyone has secret identity, they are good characters. So let's just run that. And what do you see over here? That okay, so let's go up, have a look at who is 16374, and uh, yeah, 16374 was TK421 who had a secret identity. Even the Tinkerer, the Skrull, had a secret identity and he was bad, and this guy was neutral. Right? So over here, when we made the conditional change, we can see that now Tinkerer, the Skrull, has a secret identity but is now good, and TK421 who had a neutral who was neutral is now also a good character. So that's a conditional change that we made, that based on their identity, we change their align, whether they're good or whether they're bad. Right? Now we can also change multiple parameters. So that is simple. You create list, align, comma id, whichever columns you want, and then whatever values you want to fit over there. So anyone with brown eyes has a bad character and is has a public identity. All right. So like Spider-Man was a good character. He currently has brown eyes, and he had a private identity. All right. So that should be the change when we apply this. So now Spider-Man is now public identity and is a bad character with brown eyes. If you see over here, Spider-Man had a secret identity. He was a good character and had brown eyes. Based on the brown eyes, we changed it to a bad character with public identity. Right. So that's pretty much it. How you can make conditional changes. Now because we have messed up our entire data frame, we have changed everything, which is not correct. You remember I had mentioned out checkpoints earlier, so we can just let me just close it up. We can just go over here and we can say that df is again equals to pd.read answer csv and modified csv file. So what will happen is now df will become normal. You can see Peter Walker again has a secret identity and he's alive and is a good character. Alright. So now we are going to be looking at aggregate statistics, which is the group by method. So let's say I have my entire data set and I want to create groups of the characters based on the year that they first appeared in. Right. So let's create a new data frame variable called grp group, and let's say that it is df.groupBy function according to the year. So if I were to run that, we have now successfully created another variable grp which stores all the groups, and let's print the first entry of each group. So let's say in 2003 I was born. Right, let's say I'm a Marvel character. So when you grouped according to the years, and 2003 was when a group of 2003 was created, all the characters along with me who first appeared in 2003 were included in that group. And let's say hypothetically that I'm the first person over there, then my name should be printed. So let's just run this, and what you get over here is that for each year, the first entry of each group is printed. So for 1939, Human Torch. For 1940, Thomas Raymond. 1941 was Captain America. All right. So he was the first character who appeared or was in the group of the people who appeared in 1941. So that's pretty much it. We also have Nick Fury's Jr. So that's his son. I didn't know that. So now, if you wanna have a look at all the entries of particular groups, as I said, if I wanna have a look at all the characters who appeared in the year 1942, I could use the get group function, and then over here I will find all the people who appeared in the year 1942. So we have about 244 people who had their first appearances in the year of 1942. All right, we got the fourth Musketeer and so on, Satan as well. Now let's do one thing. We found this entire group, right? And let's say I want to find the mean of this value of the number of appearances that they have made. If I want to find the mean of that, what I can do is I can use the df.groupby function again and do a dot mean. And what this function will do is it will give me the mean of all the different groups. So for each year, you will have a value which shows its mean over there. So let's run this. And what we get over here is that 1939, all the people who appeared in 1939, when you took the value of the number of appearances they have made and you averaged it out, you found the mean of all of those values, you received the answer as 15.34. So over here we had a look at 1942, right? 1942 it was 1.69. All right, so just remember this number 1.69 is 13 squared divided by 100. Right, so let's do remember this 169, and let's run this function where what we're going to do is we're going to sort the values in the descending order. Yeah, if you were to run 1942 over here, we would receive 244 rows. Over here as well, we had 244 years, 244 rows, my bad. And if we were to find the mean of new DF, if we were to run that, we would receive our friend 1.69 over here again. So that's one feature of this. Another feature is that we can, as we found the mean over here, we could find the sum as well. So the sum of everyone's appearances. So let's say someone appears for 5 times, someone appears 10 times, someone appears 20 times. So 20, 10, 5 is 35. So we should receive a value for that. So let's run that, and let's arrange them in a descending order. So 1963 was where the sum of appearances was the most, but then the average was the greatest in 1962, I guess, from this data over here. Yeah. Uh, Now let's just again do the same, right? For our new data frame, we found 401, right? Uh, for the appearances column of our new data frame, and new data frame again, if I remind you, it's the 1942 year. And let's do one thing. Let's change the new data. Let's redefine the new DF here. Let's copy this code, and what do you want to confirm? Let's say you want to confirm 1963. If that has been found out in the right manner, let's just create a new code. Let's just redefine UTF to the year 1963, right? And let's run that. And now let's have a look at the appearances column of everyone whose year value was 1963, and let's do a sum of it. So let's run that, and we received 25046, which is 25046, the same as over here. That was the sum function for you. Now there's again a count function. So if you were to run that, it will count all of the number of people over there, right? So again, over here, 1942 had 244 people, so it tells us how many entries are over here, and we can see one thing, that there are some null values over here. So like ID, uh, we are supposed to have 244 people, so there are 244 names over here, but then I think the ID of about 9 people is missing, right? They might have null values over there. That's why it shows you that there are only 235 values over here, 240 over here, four values are missing from the aligned column. So that's some further data processing that we'll be having a look at in the future, in the next videos, or in the next couple of videos. So that this function will give you the count of each group according to each column, and that will be helpful for you to find missing values as well. Now, as we saw over here that there are some missing values, what we can do is that we can introduce a new column called count. Remember, we introduced a new column called total. Let's introduce a new column called count, and all of them have the value 1 over there. All right, and let's print a data frame again. So everywhere we have got a new column, and all of the entries have the value one in them, and then we could again perform this function on just one specific column count, and what we'll receive is the count, that how many people are there in each group. So 1939 group has 69 people, 1942 group has 244 people, and that's accurate. uh, we can also add multiple subtypes to our data set to count. So let me just run this over here, and what you will get is that people in 1939 with one appearance, 42 people are there. There are 8 people with 2 appearances. There are 2 people with 3 appearances, and so on. Alright. So even that's a way to further segregate your entire data set, further segregate your entire groups. Now we are heading to the large part of Pandas, which is working with large amounts of data. So, when we have a very big data set, what we need to sometimes do is that over here, like we had 13,000 entries over it. All right. So sometimes it becomes a bit difficult for our machine to work with that. So what we can do is we can divide the entire data set into certain chunks, and then whenever we are doing some machine learning process, we can do that process on that particular chunk only, right? So let's create chunks with the size 5, or let's increase that to 10, right? So now we'll have multiple chunks with 10 entries in them. So let's run this, and this will take a bit time, so let's just wait for it. Okay, so if we were to scroll, now scrolling up is a very long thing, so let's just start from the end, right? What we have done in this for loop over here is that we have first printed chunk data frame, and then we have printed the data frame, all right, the 10 chunk, then 10 entries of the chunk. So what happens over here is this is the last chunk we are having a look at. So chunk data frame, and it has six entries, that is 16, 3, 7, 0 to 7, 5, and these are just its entire entry. So we have got 6 entries in this the last chunk. This chunk obviously has 10 entries over here, right? So let's say this chunk from 16, 360 to 369, alright, so that's 10 entries. So this is your one chunk, and all of these are the columns of their entries. So this is how we can divide the entire data set into small chunks and then perform operations on that. So I think we are now done with pandas. There are a lot of other functions of pandas, and you can have a look at them at the pandas documentation, right? Uh, you can search for pandas documentation. You can click on the first link, pandas.pydia.org, and this is the entire documentation. And you can go to the getting started thing, and over here you've got getting started tutorials, and you can just read through it. You can have a look at all the different functions over here. Sometimes if you have any doubts, you can also just search for it. So let's say I have a doubt with the group by function. I can write pandas group by, right? And we go to pandas.dataframe.group by over here, and what we find is that inside the data frame you got pandas.dataframe.group by, and all of the things that you need to know about the group by function has been written over here. So this is the entire dictionary of pandas, and I have tried to cover a majority of all the important functions in my entire core in this entire video regarding pandas. But obviously, pandas is a very big thing, and covering all of it is not possible. So have a look at it. If you ever feel some question, if you ever have a doubt, you can always send me an email or put a comment over here, or you can also do a Google search first before contacting me, and just search for something like pandas group by function, and just go through this one document over here. So yeah, that's pretty much it for this video, and we'll meet in the next one where we cover NumPy. Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe for more of such videos. Give me a follow on Twitter at Karia. And if you have any doubts, you can leave them in the comment section below, or you can send me an email at ask.kevinpgaria@gmail.com.